Hey Terrence, all right, so let's talk about this problem here, the system of equation, and here you have to use the elimination method, right? All right, so there are three situations for a systems of linear equation. The first one would be the, the most common one is that you find a value for x and y, right? Second one would be a no solution, and the third one would be that you have infinitely many solutions for a point, right? If In one of my previous video, I believe it was last week or the week before that when I talked about system of equation. Well, the first situation where you have a value for x and y, it means that the two lines, cross at one point. So you will have this situation, right? You have line one, and then line two, for example, and then this is your solution, xy. Okay, so we have a value for x and y. Then the second situation is you have your x and y coordinate, and then you have two parallel lines, right? If you have two parallel lines, then there's no intersection between those two lines, so therefore there's no solution. Okay, and all it means is that those two equations are inconsistent. Uh, you know, they're not alike. And then the third situation is that you have the coordinate plane here, and then the two lines. Let me draw one line. Oops, let me back up this one. You have one line, and then the other one, I'm just going to put it in the color. It's overlapping the other one, meaning that they are equivalent. It's pretty much the same line. Okay, and in this scenario, you have infinitely many solutions for a ordered pair x, y, meaning that all those, well, let me use another color, the red one, that here you have a point here, x, y, and they satisfy this two lines, right? And you have another one here, right? They're overlapping, so you have another point, and so on. So you have infinitely many solutions throughout those two lines that are equivalent. So those are the three situations that you can get. Now, using the elimination method, how do you recognize this one and this one? All right, so this is what we're going to do. So let's solve by elimination. So by now you should know that, okay, my goal is to add those two equation vertically so that I can cancel out one of the variable. In this case, nothing's canceling out right now, but if I multiply the bottom one by 3, for example, right, because I want this value, -3, to be the opposite of 9. So I'm multiplying by 3, and so let me write the first equation the same way, -3y equal to -18, and then if I multiply all the terms by 3, I get -18x plus 3y equal to 18. But there's something that's happening here, is that, oops, sorry, I put -18, I'm not quite sure why. -9x, 3 times -3 is 9x. Alright, so when I'm adding vertically, the x term cancel out, right? And it gives you 0, right? You don't have to put 0, x is just 0. And then you realize also that the y term also cancel out because -3 plus 3 is 0. So 0y, which is 0. They're both canceling out. It gets 0. And that's equal to, but then now, on the other side, you see that you have -18 equal to, no, -18 plus 18 is also equal to 0. Okay, so we have a value being equal to another value, right? So forget the x and the y variable. So 0x plus 0y is just 0, right? It doesn't matter if you have 0 times anything is 0, 0 times anything is 0. So we have a value of 0. And so now we don't have an x or y variable, so you determine if this sentence or this statement is true, right? And we know it's true because 0 is equal to 0, right? So it's a true statement. In a true statement, then we have this situation, because those two equations, this one and this one, are equivalent. All I have to do is multiply by 3, and I'm actually getting the same, right? If I were to multiply by -3, for example, right, I will get exactly the same equation, right? And so they are equivalent, okay? So this is the scenario. So if you have a true statement, right, then this is a scenario that you get infinitely many solutions for x and y, okay? You did send me the, let me see, the picture. I don't know if I have it, no, I don't. Anyway, it doesn't matter. Okay, so this is the set. If it was a no solution, for example, you will have a scenario where it will be, the x term and the y term will cancel out automatically. But now, you may not have -18 and 18. You may have 18 and 18, for example. It will be 36. And we know that 0 is not equal to 36. So it becomes a false statement. That's uh, hypothetical, right? And if you get your false statement, then there is no solution. Okay, so that's about it for my explanation. Hopefully you can use that for your homework or your midterm. All right, so I am done.